Hi, everyone, and thank you for sticking out through the weather, whether it's by choice or by force. So, before we get into this talk, I just wanted to comment. This is a talk on building real-time BI systems, really focusing on streaming data. And while we're going to talk through an example with Kafka, Spark, and Kudu, you can implement this kind of same type of architecture with nearly any type of data store. And so we're going to go through some of the key characteristics that we think of at Zoom Data when we think of streaming data. So at Zoom Data, streaming data takes on three distinct kinds of drivers or constructs. One is the need for data freshness. Zoom Data users and consumers of Zoom Data, or just analytics in general, have a low tolerance for working with last night's data or the data from a week ago or things like that. As you see in this conference itself, there's so many talks about streaming infrastructures and building up that kind of ingestion pipeline where you're moving away from a batch-oriented process and much more into a real-time or streaming feed. The other piece that's driving this is the time to analytics. So as users want to work with the freshest data, they also want to be able to start visualizing data very quickly. They don't want to have to model the data to a large extent before getting into it and really trying to figure out what's going on there. And this is in part because of several different reasons. What we see from our work with our various different customers and things, there's a high need to deal with a lot of variety of data as more streaming use cases are coming into practice. Our users and consumers of Zoom Data are identifying that they no longer can maintain a single schema for a number of different use cases. They have to be variable and get into that time to adjustment. So the other piece is that there's a lot more exploratory analysis happening. There's a need to look at the data before assessing whether or not to go and undertake additional activities, whether they're machine learning activities or other kinds of activities to further enrich the data or understand that. And then there's usually some utility or time to utility for the analytic itself. So users tend to have a limited time to actually impact and make a business decision based on the data that they're seeing operationally. There's other things that folks can do to drive utility of the data, but usually, like in ad tech or other kinds of industries, more and more we're seeing additional use cases where there's a low time to actually affect change of what's going on. The third piece is business context. So it's not enough to see the data change as it's happening right there. You also need to understand what happened last week, what happened last month, what's been happening year over year. If you're in the retail industry and you're looking at Black Friday and you're watching like Black Friday sales and things like that, you want to be able to go back and see, well, how's that, how was my performance as far as like last Thanksgiving or other kinds of major events. So all of this streaming data needs a graphical construct to inform the user about what's going on with the data. And there are a few key things to this construct. What you're seeing is our interface, but really there are a few things to note here. One is visualizations need to be able to react to the data as it's coming in, provide that visual cue. But if you're dealing with streaming data, more than likely you're dealing with a time or event time horizon. So this is another form of context that users need to be able to kind of work with. The other piece to that is the ability to actually manipulate the stream, to be able to pause, go back, rewind, see what's going on, and get to some interesting analysis through the animation of data. Or even do different kinds of windowing analyses, like rolling windows or looking at a cumulative picture of the data. So how are people doing this? There's no shortage of streaming architectures and general kind of roadmaps, but usually they kind of consist of a few key things. So you have your event that's being issued off a sensor or out of a transaction or something to that effect. And usually there's some kind of queuing mechanism, either Kafka that we've heard a lot about at this conference, or in more traditional settings, JMS, RabbitMQ, even MQ series or things like that. Then there's usually some level of stream processing framework. So Spark streaming, there's Flink. More than likely, a lot of folks have rolled their own at one point if they've been working with streaming data long enough. And so that's all well and good. You're getting your business logic in, you're finding a way to deal with and manipulate the data. You're dealing with things like back pressure from the stream coming in, and you're handling that effectively. But now what? You got to land it somewhere. You got to do something with it. You need that persistence profile. So what have folks been doing? So when we first started out working with streaming infrastructures, there was a lot of move and a lot of work to just land the data into HDFS. And we would come in and our customers would be like, okay, we got our data in HDFS. Great, we just put Zoom data on top of it and we're good, right? Well, not exactly. You need to think about query. HDFS is a pendulum file format. You've got your data serialized, but you don't have anything that you can use to actually interact with it. So what about other kinds of stores like Cassandra? Really, really great for quick lookup and understanding about that. You've even may implemented an architecture where you're doing inline aggregation in your stream, and you've got your windows and you're persisting that to Cassandra. And those have been there are many successful implementations like that. Or you're implementing some kind of Lambda, and so there's a lot of work that's been done on Lambda architectures and how to manifest that with your speed layer and batch layer. But let's take a look about that and see kind of under the covers what's really going on with Lambda. So with Lambda, you're going to be streaming your data to either HDFS or some other kind of store. And you might, if it's HDFS, you might keep some of that data in Avro. You might be doing your own kind of compactions into a columnar format like Parquet or ORC. And then you might expose it via Hive or some other mechanism like Spark SQL or Impala. Or you could be using some of the capabilities of Spark SQL itself or Impala itself and doing some kind of speed layer in Avro union with your historical batch layer in Parquet or ORC. This works okay to a point. It's tough to kind of, if you've got pre-aggregated data, then you get into issues with dealing with things like distinct count. And so it still requires a lot of manual management. I mean, you're doing a lot of heavy lifting, going back in, doing your compactions and things like that. So the other big thing where this kind of falls apart, and I think one thing that a lot of the talk about streaming has kind of missed is that, yeah, it's great to stream an event. An event is kind of treated as an immutable thing almost, and then you're just dealing with that. But in the business world, you have transactions. You also have restatements, which are these really ugly things that cause a lot of pain and suffering for any data engineer. So what happens with restatements? You got to figure out, like in your partition scheme, what partitions were affected. You got to go and figure out how you're going to apply the restatement and then recompute those partitions and either drop and replace them with new data or update that. And that really doesn't fit in very well with the streaming world. If you've got to be able to do this, you got to be able to actually issue updates and or upserts as you're getting these transactions in. You got to be able to recompute on the fly. So here's an area where Kudu really comes in. And for those who don't know what Kudu is, It's a storage engine for structured data, and it supports random access and is geared for analytical efficiency. So it takes on a columnar-based format for the data. And so why should you care about it? Well, for all the reasons that I just noted about how to manage your stream and understand like your persistence profile with that, makes your ad hoc analysis of your data much, much, much easier. And that's why we like it as well, right? Because we're primarily focused on ad hoc analysis. And to do that, you really have to get away from pre-computed aggregates, from other types of pre-processing that kind of turns your ability to issue ad hoc queries into a kind of much more rigid and singular experience. So we do a lot of work with Impala and Parquet already, and as well as Spark. But some of the things that we noticed with Kudu is that you get pretty much near similar performance as you do with Parquet for a lot of similar analytical workloads. So this is really good. The data management model is really, really simple. It's pretty much create your table and go with some exceptions that I'll get into there. And then it's allowing a lot of our users to handle new cases of streaming use cases and workloads. And this is really interesting, as we've seen a lot of customers that have gone through all these growing pains, and now they're looking at Kudu and other technologies as well as a way to kind of get around some of the issues with this. So great, let's just work with Kudu. We can ingest the data at like really high throughput. We can support analytic queries. Why not just use it and deal with it? Well, you still got to think about your data model. You still got to think about how that's going to work for you. You got to think about a few things like what your keys are. You got to understand how you're going to represent time within your data, because that's what is going to be key to drive off of. And if you've been dealing with large data sets, and we've all been doing that here at Spark Summit, you're really going to have to understand your partition scheme, cardinality of attributes, and your key structure. The one important thing about key structure in Kudu is that your key structure is your immutable part. So you can do updates on other things, but your key structure is that one thing that is pretty static. So let's put all of this together. Imagine we have a fruit stand, and we sell fruits via our phone and take remote orders from buyers. And our transactions, in terms of the transaction payload, looks something like, got an order ID, I got a timestamp for that order, that's comprising my key, and then I've got the fruit, the price, customer ID, your phone, address, things like that. So how's that going to look in Kudu? Well, first thing I need to do is I need to create my table. And this is all Impala SQL syntax. But if you see the Kudu pieces at the bottom here, it's really a storage handler. So you think of it much of the same way you think about Parquet. Parquet has a schema that's there, and it's defined in Parquet. That's your schema. This is, remember, like Impala or Spark SQL, they're all schema on read type of operations. So your storage subsystem is handling that. Just think about it like as a more intelligent storage subsystem that's going to do a lot of nuts and bolts data management for you. But you do need to tell it the name, your key columns, and some other bits. A couple other things to note are some of the performance increases that you can get out of Kudu by doing things like dictionary encoding, where it'll take your string text and kind of serialize that into a more concise bit format. And these are really great for performance improvements, especially on the analytic side. If you think about low cardinality group bys and being able to do that really, really quickly, using these kind of advanced encodings is a key there. The other thing is this is a distributed system, so you're also able to stripe that data and not have to think about a priori how you're going to get distribution. You can use a hash partition off of your key and get that into a certain number of buckets. And Kudu will take care of striping that as long as you've got enough distribution in your key structure. It'll take care of striping that across your different nodes. So let's take a look and see some of this in action. So with Kudu, with your streaming infrastructure, really what you're going to need is your queue, your streaming source, your Spark streaming application, and your data writer. As you can kind of see here depicted in this diagram, we've got Kudu as a sink for the stream, and then as a source for Zoom data. Now, why do it this way? Why not just use Kafka Connect and write directly into Kudu? You can definitely do that. Why have two separate topics in your Kafka queue? There's a lot of interesting reasons why to do it this way. So one is, when you're building your streaming application, you want to be able to isolate different aspects of your streaming load. So your ingest rate, you want to be able to kind of bring that data in and have it there and available, and be able to kind of pull that off as you need it. And so that's why you would have a separate landing area, if you will, using Kafka more as like a staging environment as you fashion up your and hook in your data pipeline. You can use Spark streaming or any kind of streaming application or technology to do this. But you're going to want to write back out to your Kafka queue. And this is an interesting way to do it. It's really like kind of replacing HDFS as what you would traditionally use in a regular Spark job when you're done with your job and serializing out to disk. But there's some good reasons to do that. One is you kind of automatically have an event infrastructure that you can build multiple taps into and handle that really, really well. A couple of things that you'll need to think through, though, is, do I have a topic for every stream? Do I have a topic for, every data format? How do I kind of manage that? You'll have to think through how you're going to maybe multiplex over a single topic and specify some additional information there. And so at some point, as we found, as we built these kinds of infrastructures for our customers, as we've been working with this technology ourselves in providing our own streaming infrastructure, is you kind of need a little bit of extra help to pull this in. Before I get to some of that, let me talk about the data writer, though. So the other piece is, as your streaming app is landing data into your other topic, you again don't want to have to necessarily have all of your infrastructure scale out equally. So you will separate out a data writer, and this is basically a subscriber to your topic that's going to take that and land that into Kudu. We do that primarily so that we can monitor the ingest rate and match that to the size and ingest rate of our Kudu cluster. You can also lever that as appropriate during the day or throughout the performance profile of your application. But as I said, we need a little bit of extra help here. So we what we had to create was a bit of some helping hands in the form of a data writer API. And really what this allows us to do is it allows us to better manage how we're writing out different topics. We can multiplex over a single topic and have different message formats and tell the writers like which ones to look for, which ones to pop off. And also, we want to be a bit more efficient, right? I mean, it's great to have your stream infrastructure set up and everything kind of on, and these pieces like polling, looking for new events. But when nothing's going on, you kind of want to be able to ratchet things back down and be a bit more elastic from the scale perspective. So to achieve some of that elasticity, we need to kind of be able to have a communication layer that said, okay, well, there's really not that much going on right now, so why don't you kind of turn yourself down, go to sleep for a while, do some other operations, and save some resources there. So the other piece to this that I mentioned in the beginning of the talk was that you really can utilize this infrastructure with any store. So you can imagine having multiple different data writers writing out to either Kudu or Solar or Elastic, writing out simultaneously, filtering off of different messages, doing different kinds of operations. So really what you can achieve with this model architecture are several layers of scalability, but also flexibility. Because I think almost everyone here who's been working with this technology and is understanding that, you're also understanding that there's a lot of emerging tech that is coming of age, and you want to be able to take advantage of that. You might find a new store that comes around that is like got better write throughput, better performance characteristics, or you may simply just need to utilize different stores for different chores, right? So you can, if you need search, you're going to want to get that into Solar Elastic, or if you just want pure analytical queries, Kudu, MemSQL, any of these other applications can do a fine job. Okay, so now I want to get to some demo. And so we said we had a fruit stand that took an API with phone-ordered fruit orders, right? So why don't we try that out a little bit? And right now we'll see we have a Spark application running. That's our Spark streaming application, and I'm just going to send it a order of kiwis. So I'll send an order of 1,000 kiwis. You can see I've got my job running. It had already processed 961 records. And so that's great. So things are working and they seem to be humming along. Now let's visualize that data. So I've got a dashboard pre-generated, and you can see we've been using this for some time, testing out this demo. But what I want to do is ask the audience to actually text in some fruit orders. We can see these things start to pop up and appear. Now, fast forward in time so we can start seeing some more rapid activity here. So we got some orders coming in. So we can see quite easily what's going on, how that's working for our little fruit stand here. See if we can get some more participation. Oh, we got some more participation. A little bit more. Has everyone figured out what the limit on the amount of fruit you can order at one time is? Has anyone figured out we have a whitelist on the fruits? All right, so we've got some really good activity going on here. But like I mentioned before, I might have this in Kudu, but I can also have it simultaneously writing to Solar. And we're still going. You can see we've got a good, steady influx of transactions here. And so I hope you guys can see how this very seemingly simple architecture can scale to support a wide number of workloads for streaming data. All right. You guys can continue to play. I'll go back to the presentation. So I do want to thank Anton at Goldman Sachs. He as you kind of maybe saw in the previous presentation, if you were around for that, he had this original Kafka fruit stand demo with MemSQL. I'd like to thank the Cloudera Kudu team for a lot of the insight that they had on Kudu optimization as we worked a lot of these use cases, and Nexmo for their SaaS SMS service that helped us get this done. I think we've got some time for questions.
Do you re-render your entire visualization for each new data, or how do you handle new data?
In Zoom data, do we re-render?
Yeah.
Yes. So we have a visualization framework that basically projects the data up to the visualizations via WebSockets. And then part of our protocol is to have that message payload be cumulative, so the viz only ever has like just what it needs to render at the time. We do a bit of work on render performance and how that works, yeah.
Hi.
Yes.
Are there any major limitations in Kudu that you guys have to either work around or live with?
Major limitations. So I think the Kudu community is like really good about spelling out the limitations. They're actually there in the Kudu documentation that you have. I think one thing early on that challenged us was a little bit about some of the maturity within like the APIs, and that's mainly from the perspective of data loading. So with Kudu, it's really much better to use the Kudu native APIs rather than trying to do insert statements through Impala or something like that. So you want to kind of have a little bit of a hybrid approach with that. You use Impala as the interface for analytics on top of Kudu, but I would stick with the Kudu direct APIs for data ingest, for sure.
We got time for a few more. Anybody else have questions?
So if you have historic data, or if you have current processes and plans in the future to implement Kudu, are there formats that lend themselves more sort of an easier integration into the architecture that you talked about, which we might currently use and consider transitioning over to this type of architecture with Kudu?
Yeah, I mean, as I mentioned in the beginning of the talk, if you're already using Parquet, you've had to solve a lot of the same concerns in terms of data structure and format. You are dealing with a columnar structure, so anything that's more or less equivalent to that can assist you with that. I think the challenge is going to be finding something that has the same type of write characteristic that's handling all of that for you. We've got other customers that are implementing similar types of infrastructures using things like MemSQL, even Elasticsearch. You saw Solar. All of these have somewhat similar characteristics, albeit like different scalability factors as you're thinking about your implementation. So if you've got historical data already and it's already in Parquet, that would be probably the next best thing to try and think through as you're thinking about a Kudu implementation.
All right, that's all the time we have for questions. Thank you.
All right, thank you.